So the marginal cost is the derivative of the cost function with respect to x. So 3 comes down and multiplies, and then the power gets reduced by 1. The 2 comes down and multiplies, the power gets reduced by 1, and then that 1 comes down and multiplies, power is now 0. So there's our derivative. And then using that notation, you could do it that way, or you could just plug in x equals 1,300 plus 100t in for every x, and then take a derivative of this new function now with respect to t. But we'll do it their way. They say it's the derivative of c with respect to x, which we have up here. Then we need to multiply that by the derivative of x, which is right here, the derivative of x with respect to t. So when we take a derivative of this, it's just 100. So that notation's quicker rather than having to plug it all in and put it in terms of t, right? So for part B, this is no longer for part A. For part B, it's going to be 0.0, is that 3x squared? Multiplying that by 100 in my head. This is 6x plus 300. Okay, so a lot quicker using that notation. And for C, use the results from part B to determine how fast the costs are increasing when t equals 3. So you just need to plug in, we've got to plug in 3 in for x. Wait. No, sorry, we've got to plug in 3 in for t. T equals 3, so plug 3 in here. So 100 times 3, and then plus that 1,300. So x is 1,600 that you're plugging in for part C. So 0.03, and then we got 1,600 squared minus 6 times 1,600 plus 300. That's 76,800, and then this next one. So now we're down to 67,200, so 67,500.